Eric Burgess here, and we are told to find the range, variance, and standard deviation for the data. So we've got here some data points. We just got to find these different things. Doesn't appear to be too bad, so let's go ahead and go after these. So first up is the range. Range is equal to the highest value, highest, minus lowest. So that's going to be here. Let's figure out which one's the highest. The 71 looks to be the highest. So that's going to be 71 minus the lowest, which here we've got 50. Anything lower than a 50? Nope. So we're going to have minus 50. If we do this, we're going to get, what is that, 21? Always a good idea to double check your work with a calculator. So we'll do 71 minus 50. We get 21. Just double check it. Don't want to miss anything because of just a silly mental math mistake. Alright, cool. So we've got our range. Now we're going to do our variance. So there is a formula for this. There's actually a couple of different formulas. I'm going to show you the easiest one. So the easiest formula, and we'll do it using the calculator way as well. The easiest formula for variance is that s squared, right? That's variance. And that's going to be equal to n times the sum of all the x's squared minus the sum of x squared over n times n minus 1. That's going to be our formula for the variance. And let's go ahead and just get it with the calculator really quick. So here's the calculator method. So first up, we need to get our data in the calculator. So we're going to go to stat and then to edit, and we're going to come in. If you've got stuff in your list, just go up to list 1 and hit clear, or whatever list you're on. You'll see it clears on the bottom. Hit down and it will update the list. And now we're going to go and enter our stuff in. So we've got 51, 60, 52, 70, 55, 50, 58, and 71. And let's go ahead and just double check we got all the numbers in there correctly. 70, 52, 60, 51. Perfect. So now we're going to come into stat, go to calculate, and in one of our stats, it'll give us the standard deviation, and from there we can get the variance. So we're going to choose number 1. Make sure your list is the correct list and that frequency list is blank. We're going to hit calculate. All right, so now that we're in here, we can see the standard deviation right here. So the standard deviation, according to the calculator, is 8.23 if you round to 2 decimal places. So this is the standard deviation by the calculator. So let's go ahead and find the variance now. So we're going to go to second quit. And we're just going to square this thing, right? Because the variance is just s squared. So if we take 8.23 and we square it, we're going to get out 67.73. Now keep in mind these are sample standard deviations and sample variances. So this is the variance that we get. So now using the formula, can we get the exact same thing? Now, in the previous video, I showed you that you could take each x value individually, square it, and add them all up and replace this value with that. So you could take like 51, square it, and add to it 60 squared, add 52 squared, add 70 squared, add them all up, and then that's the number that would go here. And then for this one, you would take all the x's, 51 plus 60 plus 52 plus 70, all the x values, and you'd add them up and put them here, and you could replace those. There's a faster way to do this though. If you come into stat and go to edit, if you use the list you have, so you put them in your list, and then we go to stat calculate one var statistics, and we're going to do the exact same thing as before, but this time you see we can actually use these to plug directly into the formula. So you see how the sum of x is given right here? So we have the sum of x as 467, and we have the sum of x squared, which is 27735. So this is just a faster way of getting these values instead of doing all this manual adding. And so I'm going to go ahead and use this method this time, just because I have an example of it in the previous video if you want to see everything done one by one by one. All right, so we're going to take this and plug them in. It also will actually tell us n. So here we've got n is equal to 8. You could just count the number of numbers we're using here, right? So we have 4 numbers here and 4 numbers here, so there's 8 numbers total. All right, so filling in the formula now, we have n, that's 8, times the sum of x squared, that is 27735, minus the sum of x, which is 467 squared, divided by n, which is 8, times n minus 1, which is 7. All right, having these things in there now, let's go ahead and put this in the calculator. So I'm going to hit alpha F1 to get to the fractions. And then we're going to type 8 times 27735, close parenthesis, minus, open parenthesis, 467, close parenthesis, square, over 8 times 7. So you literally just type it exactly the same as how it looks here. You hit enter, we get a fraction. We're going to convert it, hit the green key, alpha, F1, and then option 4 gives us fraction to decimal. So we're going to choose 4, hit enter, and we get a standard deviation. All right, this is a variance. My apologies. A variance of 67.69, which if we round will become 0.7. And this is going to be our variance. And if we take the square root of this, we will get the standard deviation. So taking the square root of this, we get, I'm going to hit second square root, which is on the square key. And then we're going to put this number in, so we can hit second and then answer down here in blue. And we get 8.23. Now let's compare this. So this is our s squared. And this is what we get using the formula. When looking at this, we get the exact same thing for the standard deviation and something that is super dang close to the calculator method. And so we could see we get the same things 2 ways. So we could write as expected, 2 different ways, got the same result. It's always really nice when that happens. And that is how you do a question like this. If you have any questions about this, feel free to drop a comment down below, subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.